Hello, grade 8 students. In this lecture, we're going to introduce a new lesson, which is trapezoid mid-segment theorem. The objectives of our lesson is to identify and apply the properties of a trapezoid, and we're going to recognize and use the mid-segment theorem in a triangle and a trapezoid. So we're going to use this theorem in two shapes, the triangle and the trapezoid, and we're going to identify and use the characteristics of an isosceles trapezoid. Let us first remember together what's the meaning of a trapezoid. A trapezoid, it's a quadrilateral because it has four sides, but the only property or the only special thing about the trapezoid is that it has only one pair of its opposite side parallel. If you look at the figure, we have only AB and DC parallel, so that's why it's a trapezoid. If AD also and BC are parallel, then it's not going to be a trapezoid, it's going to be a parallelogram. So if I have only one pair of opposite sides parallel, then it's a trapezoid. So ABCD is a trapezoid. We have AB parallel to DC. We can say that AD and BC are two legs. AC and BD are two diagonals. CD is the big base and AB is the small base. Also, we have special trapezoids. We have the right trapezoid, where we have two right angles. Of course, only two, because if we have four right angles, then it's going to be rectangle or a square. So if I have only two, that's why, if you still remember in the special parallelogram, when we used to prove geometrical shape rectangle, I ask you to prove three right angles, because if you have only two, that doesn't mean it's a rectangle. It could be, as you can see, a right trapezoid. So the right trapezoid, it has only two right angles, and of course it has one pair of its opposite side parallel. Another special trapezoid, it's the isosceles trapezoid. The isosceles trapezoid is where the other two sides that are not parallel, they are equal in size or in length. So the legs are equal, the adjacent angles are equal, and we have the bases have the same perpendicular bisector. So if you do the perpendicular bisector of the small base, it's the same as the perpendicular bisector of the big base. Now let us start with our theorem. First in a triangle, then we're going to learn it in a trapezoid. So in a triangle, as you can see here, we have a triangle ABC, any triangle. If M is the midpoint of AB, okay, and N is the midpoint of AC, so M is the midpoint of AB and N is the midpoint of AC. If you join those two midpoints, if you join the two midpoints in a line, so if you construct a line, as you can see here, the line MN that joins the two midpoints, then you're going to get a straight line MN, which is parallel to the base BC. Not only parallel, but it's also equal, it's half. So if BC, for example, is 6, then MN is 3. I'm going to repeat. If you have a triangle, you construct the first midpoint and the second midpoint, and you join them with a line. This line is going to be parallel to the base BC and equal its half. The same theorem applies in a trapezoid. So if you have M, which is the midpoint of AD, N, which is the midpoint of BC, then MN is parallel to AB and at the same time is going to be parallel to DC. Not only parallel, but MN is equal the small base plus the big base over 2. In this exercise, we have ABC, it's an equilateral triangle. You know that the equilateral triangle, it has 3 equal sides. Of perimeter 12. What's the meaning of perimeter? It's the sum of all sides. So if the sum of all sides in this triangle is 12 and all the sides are equal, then every side is 6 centimeters. Let me write this for you. So here we're going to have every side it's 6 centimeters. Sorry, it's 4 centimeters because 12 is the perimeter of all sides, 3 equal sides, then every side is 4 centimeters. So AB is 4, AC is 4, and BC is 4 centimeters. Now they told us that M, N, and P are respectively the midpoints of AB, AC, and BC. So M is the midpoint of AB, N is the midpoint of AC, and P is the midpoint of BC. So now we're going to get all the parts are equal, which is 2 centimeters. So this is 2, this is 2, this is 2 centimeters, and this is 2 centimeters. Okay, I wish that till now everything is clear for you. We need to calculate the perimeter of triangle MNP. In order to calculate the perimeter of the triangle, we need to find the sides MN, NP, and MP. Let us first try to find MN. So, you know that M is the midpoint of, we start in triangle ABC, we have M is the midpoint of AB, N is the midpoint of AC. So the joining line, which is MN, is parallel to BC and equal its half. BC is 4, then MN is 2, using mid-segment theorem. Okay, let us see this. So ABC, this is the perimeter. M is the midpoint of AB and N is the midpoint of AC, then MN equals BC over 2, which is 2 centimeters. The same thing we're going to do when we join the other two midpoints. N is the midpoint of AC, P is the midpoint of BC, then NP equals AB over 2, which is also 2 centimeters. Now let us look for the third joining line. P is the midpoint of BC. M is the midpoint of BA. Then MP equals AC over 2, which is also 2 centimeters. Now the perimeter of MNP is the sum of all sides, MN, MP, and NP. So 2 plus 2 plus 2 equals 6 centimeters. Also, don't forget that you have here to mention using, here you have to put the rule, or here, sorry. Okay, at least write it one time, so using mid-segment theorem in a triangle. Now another exercise where we have a trapezoid. We have ABCD is a right trapezoid. Let us put the given. Whenever you see it's a trapezoid, let us put the given. So we have AD, it's parallel to BC, and it's a right trapezoid, so here we have two right angles. We are asked to prove that MA, let me join MA, equals MB. So as if they are asking us to prove that M is equidistant. Equidistant means it belongs to the perpendicular bisector. M is the midpoint of DC, right? N is the midpoint of AB. Then MN is parallel to AD, it's parallel to BC. This is using what? Mid-segment theorem. So now I have here all these lines are parallel. So if all the lines are parallel, then all of them, they are perpendicular to the same line, which is AB. So now I just proved that this is perpendicular. So MN is perpendicular to AB and N is the midpoint of AB, then MN is definitely the perpendicular bisector. So any point on this perpendicular bisector like M is equidistant from A and B, so MA equals MB.